Morning everyone, hope you're all having a nice day, and thanks for attending my session. My name's Tim Dukes and I'm the Technical Director at Origin Engineering. Just as a short way of introduction, as I just mentioned there, my name is Tim Dukes, and I basically I'm the day-to-day contact for most of our customers at Origin. I'm sort of customer facing, providing technical support, training, and I also define a lot of the Origin's product sort of strategy. So I'll just go through a bit of the agenda of this this presentation and sort of what we're going to be covering. So in a second, I'll briefly describe sort of who we are at Origin Engineering and why we sort of advocate for simulation earlier in the design process. I'll briefly touch on the sort of barriers to entry, barriers to adopting simulation, and then the actual product that we're going to be focusing on today is Ansys Discovery. So there'll be a little demonstration, or a 30-minute demonstration of the actual software. And then if you've got any questions, we'll have our contact details at the end, but feel free to reach out with any questions you may have as well. So who are Origin Engineering? So Origin are a fairly new company. We've actually only been around 7 months. However, we are sort of an evolution of a previous company that I used to work for the last 9 years. We have around 200 customers. We're based purely in the UK and Ireland, and our focus is around design and simulation for sort of manufacturing. And we do, as I mentioned, we do advocate for that simulation earlier in the design process. We feel that if you do simulation earlier in the design process, then generally this will lead to sort of more optimized products, shorter development cycle, and hopefully that will lead to increasing cost savings as well. So as I mentioned, the tool that we'll be looking at today is Ansys Discovery, but we do sell a number of other simulation sort of led design products in our product portfolio. So yes, so as mentioned, sort of why do we advocate for simulation led design? Just I'll first touch on a few like sort of barriers to sort of entry in the simulation market. I think traditionally simulation may have been left to the CAE expert or potentially outsourced, and the reason these might be is because of high costs or needing extensive training on the products. But we feel that things are changing now, and the products are coming down in cost, and they're a lot easier to use. And if you can incorporate them at the design stage, this will allow designers to fully understand their products and hopefully design better products. Just a couple of examples of incorporating simulation early in the design process can help. One could be, as I say, choosing the best materials. Let's say, for example, you are designing a product that's going to be maybe cast, allowing you to quickly study whether this part can be made out of cast iron or whether it can be made out of aluminium, and quickly study the benefits of both materials. This allows you to quickly understand which material you can use, or which material is the optimal material to use, and this can potentially lead to sort of cost savings as well. You might also have 3 concepts and you just want to quickly simulate them, work out which is the actual optimal design, and this will lead to reduced prototyping and also expensive like trial and error. The last thing we'll just touch on is sort of generally just being better than your competition. If you are bidding for work and you can prove that your solution works through simulation, you can show analysis of your designs and how your product will behave in the real world. If your competitors aren't doing that, then generally that will show and give you an advantage over them. Next slide. So now we're just going to quickly go over the what is the Ansys Discovery solution. So the Ansys Discovery is a multiple physics tool, and it allows you to do structural analysis, so stress analysis, fluid analysis, thermal analysis, and also topology optimization. So this is all available in this sort of one tool. Just to briefly sort of explain the why we sort of advocate for using Ansys Discovery. First of all, it's very quick. You get real-time results, so you change something within a few seconds, you're going to get updates, and this you'll see in the demo very shortly. We do feel it is one of the fastest tools, simulation tools on the market, and the reason it is because it uses the graphics processor. So it uses your graphics card to actually simulate. It's very easy to use. Generally, it takes 1 day of training to get up and running, and it's at a fairly low cost as well. And it's a dedicated simulation tool with design tools inbuilt to it. So the Ansys Discovery sort of workflow is generally you can design within Ansys Discovery, or you can import a model. We can import models from anywhere, so it doesn't really matter where your model was created, whether it was created in SolidWorks, CATIA. We can import it into Ansys Discovery, and we can modify and work on it as if you created it within the product itself, and very quickly set up simulations on it. So that's sort of the first step: import your model and prep it for simulation. The second step is to actually analyze and start running simulations. So in the demo that you'll shortly see in the next 30 seconds to a minute, we're going to be looking at the explore stage within Ansys Discovery. And this is Ansys Discovery has two modes of working. One is the explore mode, one is the refine mode. The explore mode allows you to get rapid results of your parts. So the next stage is the refine mode, and this is what you'd probably consider more traditional meshing. This allows you to actually mesh your part, and this uses the CPU and maybe to refine your results and get slightly higher accuracy results, you might say. I've flown through these slides a little bit just because we push for time, and there is a live demonstration. So we will look at the actual demonstration of the products, and hopefully that'll give you a flavour for it. So the next thing we'll be seeing, lastly, just to mention this, the Discovery does integrate totally with Ansys' sort of flagship products. So if you are aware of Mechanical Fluent, we can send our models directly from Discovery to those products. This is going to be the demo route. So we're going to be looking at geometry prep. We're going to look at an FEA example, a CFD example, a thermal example, and a topology optimization, all within 30 minutes. So hopefully that shows the power of Discovery. So this is the live video. I'm going to press play, and hopefully you guys can get a flavour of what Discovery does. First of all, we'll just start with the user interface of Ansys Discovery, and then we'll get into some of the geometry preparation tools and creation/modification tools. We'll then look at a structural example, FEA, then go on to a CFD example, and then into a thermal, and hopefully a topology optimization example as well. That should sort of explain the speed of Discovery, being able of all, we'll just start with the user interface of Ansys Discovery, and then we'll get into some of the geometry preparation tools and creation/modification tools. We'll then look at a structural example, FEA, then go on to a CFD example, and then into a thermal, and hopefully a topology optimization example as well. That should sort of explain the speed of Discovery, being able to do all of those simulations hopefully in around 30 minutes-ish. But first of all, we'll start with just quickly go through the user interface. First of all, Ansys Discovery has sort of three modes of working. You've got your model mode, which is where you can do all your geometry creation, modification, preparation. You've got your explore mode, and this is the mode that we'll be focusing on most. This is where you can do rapid exploration and rapid simulations, instantaneous results. And this is using the GPU, the graphics processor. We've then got the refine mode, where you do get full mesh controls, and you can go into higher fidelity results, and these are obviously using the Ansys full Ansys solvers under the hood. Any of the simulations or setups that you see we do in the explore mode can be taken straight into the refine mode and run. But obviously, due due to time constraints, we'll just be running these in the explore mode and hopefully getting some results for those. First of all, very first thing we'll look at is just our import and export options, because we can open files from most formats. So hopefully you can see here we've got your ASYS, your 2D AutoCAD, all your CATIA formats, Creo, IGES, Steps, JT, SolidWorks. Most CAD formats you can think of, we can import into Ansys Discovery. So the first thing, just to quickly go over the UI, we've got a number of tabs along the top. We've got a design tab. This allows you to modify and create geometry. We have got a sub-D tool, which allows you to create sub-D models or turn previous models into sub-D and modify them that way. Display tab does what it says. We have a measure tab, again, allows you to take measurements from things. A facets tab allows you to work more closely with STL files, and we can actually run simulations on STL geometry as well. We've got a repair tab. Sometimes if you bring a model into a CAD or analysis tool and it's not a watertight solid, or it's got corruptions, you do need to repair it before you run a simulation on it. Then we've got our prepare tab. So this is a geometry preparation tab. Great tools in here are tools like things like volume extract. Obviously we've got imprint edges, enclosures. So there's a number of tools in here that will help with your geometry preparation and setup for simulation. And then we have our simulation tab, and this is where you will create a simulation depending on what you are looking to create, whether that be a structural, a fluid, or a thermal. And we do also, you can also do this via this quick access toolbar here. So all these tools you see in these tabs will also be here. The first thing I just quickly want to run through is some of our design tools and modeling tools. So geometry preparation tools. So I've just imported a model into Ansys Discovery. It doesn't really matter if we're in the model tab or the explore tab or any of the other tabs. You can use all these tools in each mode. So I'll just go into the model mode. A lot of the time, if you are meshing a model, you might want to refine your model a little bit, remove small faces, especially embossing and engraving, or you actually might want to change your model in some way. So, so we have tools to do all that sort of thing. So, for example, in this model, I can clearly see there's a bit of embossing and engraving. In the explore mode, we don't actually need to defeature anything. We would be able to run a simulation on this model. But if you wanted to go into refine mode and make sure you don't have any mesh issues, you might want to start removing things that aren't really necessary for the simulation. So first of all, we could box select this embossing here, and we can use one of our defeaturing tools, which is the fill tool, and that would allow us to actually just get rid of that very, very quickly. Another great tool in Ansys Discovery is the feature select, power select, we call it. So for example, I've clicked on this this radius here. Using this tool here, I can actually search for all radiuses of the same size, so I can find all the radiuses in this model that are 1 mil. I can see that I've picked up on 32 faces. Hopefully you can see them all highlighted there. If I did want to get rid of them, I could literally use this fill tool again, defeaturing tool, and you can see that all those 1 mil rads have now actually disappeared. Another nice thing is we can use some of our other geometry tools, such as pull. For example, if these holes weren't meant to be 5.461, they're meant to be 6 mil, or you wanted to make a quick geometry change, you can see I've just selected them both, typed in 6, and now the model's updated. So I'm just making these live changes on the model, and this is again great for rapid exploration of models when doing simulations. So if you run a simulation on this, a structural one, and you find that maybe you need to make a quick change, maybe I need to change the height of this area here, I can use my move tool very quickly, increase the size of this to suit, and I can maybe make another variation and the model's slightly higher. So we're just making those quick design changes, and all this is possible in Ansys Discovery. That's just a very, very quick intro into sort of model prep, model creation, and we can create models from scratch as well, and simplification. But obviously what we're going to move straight into is an FEA example. So I'm going to open up a model, and we're going to look at a structural simulation. So I've just opened up the model for the structural or FEA simulation. First thing I've done is I've used my quick scope tool in the simulation tab to basically specify the pieces that I actually want to run a simulation on. So I've chosen these 4 highlighted pieces here. What I'll do now, just to separate everything, is do a hide all suppressed, and that'll hide everything that's not actually involved in the simulation. Another way of doing that is basically through your actual structure tree, and you can basically just turn off the things that you don't want in the simulation, and include or exclude the ones that you actually do. So now that we've done that, the next step is to actually start applying some structural conditions. And the first thing that I'm going to do is apply some supports. So I'm going to apply a hinge support through these 2 faces here. So we can do this using our little tool guide here, or we can go to our structural tab along here, and then we can go to our supports. And in this instance, it's going to be a hinge support. So I'm going to hit the tick box, accept that. And as I do that, we can see our tree, our physics tree on the right, start to be created. So I'm going to apply a few more supports. Let's do one for here and here. And let's do the final one through these 4 pieces down below here. So we've applied our supports as such. And you'll notice that I've applied these coaxially, so obviously we couldn't apply them all together, only the ones sharing an axis can be applied as hinge supports. The next thing to do is, before I go on to add a force somewhere, I'm actually going to do a bit of defeaturing. So looking at the model, there is still some little 1 mil rads along this edge, and if I look at the bottom side, they're no longer there. So let's use our power select tool to quickly defeature those. So if I click on the face and use my power select tool down here, I can select all the rounds equal to 1 mil. You'll notice that's picked up on 72 faces. We can go into our design tab and hit the fill tool. We can see those instantly get removed. Now let's do a bit of defeature on this thread. So obviously I might not want that thread there, especially if I'm going to mesh this part later on. A thread might get in the way, it might not be necessary. So let's do a big box select around this whole area, and then I'm going to hold control and deselect this area here. Let's just turn off our power select tool, and that should allow me just to fill in this thread up to this line here. So again, I'm going to use the F key or the fill tool, and that allows me to fill in that area there. So again, just defeaturing, preparing that area for simulation. So next step is to apply a force. So I'm going to apply a force to these 2 faces. I'm going to use my quick access guide here. So I'm doing a structural simulation, and then I can apply the force tool as such. So I'm going to apply it here, and I can type in negative or positive values. So I'm going to apply a negative 2000 in the X direction, or minus X. I'm going to apply a positive 10,000 in the Y direction, and let's do a negative 2000 in the Z. So you can see you can apply these any way we want, or we can use a remote point. Once happy with it, let's just hit the escape key a couple of times, and now we can see our force has been set. One thing we're going to look at now is the contacts. So if I look at my bonded contacts here, if I double click, I can see at the moment I've got 3 contact pairs, and we can see them by these little points here. I don't want all these to be, and these are at the moment bonded, so I might not want all these to be bonded. So I'm going to set this one here first to permanently bonded, as I want that to be that. These other 2 I'm going to actually exclude from contact detection. So I'm going to use this tool here, and they're going to be excluded from contact detection because I want to create my own contacts. So again, to do this, I'm going to first select on this point here. I'm going to use my quick access guide. I'm going to set up a joint, and selecting this tool here allows me to select secondary faces. I'm going to select these 2 as secondary faces. I'm going to hit the tick box. So I've created my first fixed joint for there. I'm going to do the second down here. Hit the tick box, and just do the same on the opposite side.
So those are all my joints connected. One nice new feature in the latest release is the ability to actually add a spring joint. So when we saw our parts, we can see that there's actually is a couple of springs. So we can apply these using our spring tool. So we can again use this tool here. This is the new spring tool. Select a secondary location. In this instance, I've actually created a point in space, and we can select longitudinal or torsional. I'm going to apply a value of 1000. So that's applied it there. I'm going to do the same thing for this one. Make sure I select the secondary faces here. Again, keep it the same and accept that there. So that's my structural setup complete. I'm still in this explore mode. Just to explain this a little bit here, this is our fidelity bar. If I go into the simulation tab, I can get a bit of a size preview. So this will tell me sort of how big my mesh is. Obviously we're not meshing it in this mode, but it will tell you how big the mesh is and give you a bit of a preview. We can obviously increase this fidelity, so you can see I can increase this slider bar, so I'm obviously going on quite a low fidelity at the moment. We can increase that obviously up to the top, and I'm ready to basically get some results. So we hit the solve button, and within a few seconds we're going to start to see some results. So it's still simulating at the moment. We are looking at displacement at the moment, and obviously we can visualize that displacement as well. So we can use this tool here to actually visualize that deformation, and we can animate it as well, so we can see how this part may animate based on my settings and my forces. So we can look at things like, if I just pause that, we can look at things like displacement. We can obviously look at high areas of stress based on our forces, and we can look at that in different values. Obviously megapascals might be the most common one we use, and we can set our bar on the right hand side to any values we choose to maybe highlight the high areas of stress or look for particular areas. Up in the right hand corner we've got things like factor of safety, obviously displacement, stress, but we can also create any, if you want to know a value in a certain area, we can hover over it and you can see it appear in the results bar on the right hand side, or you can actually create a monitor and select a result and have a particular stress value on a face or a hole, and so on. So that's just a very, very quick example of a structural simulation sort of setup through to results, again using the explore stage. And we'll now move on to a fluid example. So I've just opened up the model that we'll be looking at the fluid flow example on. The first thing we might want to do when we're looking at a fluid flow example is, if this is an internal flow, we can also do external flow, but we might want to extract the volume. So in the Prepare tab in Ansys Discovery, we've got a great volume extract tool. So the way this works is we click any face with an opening. So these three faces have got the opening in this model, and then we select a seed face or any internal face. This also works on assemblies, as long as your assemblies are watertight. We can extract very complex volumes very, very quickly using that volume extract tool. The next thing we want to do is actually set up our inlets. So this and this face and the opposite one are going to both be inlets. So I'm going to set up this face as an inlet, and we can specify velocity, mass flow rate, pressure, swirling flow. I'm going to use velocity. I'm going to specify 1 meter per second. I'm going to do the same on the opposite side. And then I'm going to choose my outlets. So these three faces here, or five faces are going to be outlets. I'm going to specify that as a 0 PA. One thing we can also do once we've created our volume is we can also overextend these outlet faces if we wish. So we can also use our modeling tools. In this instance, I'm using the pull tool, which is found in the design tab. And if we want to, we can overextend them sometimes in CFD simulations. We might want to overextend those so there's no sort of turbulent flow at the outlets. So now that we've done that, we can look to our physics tree on the left hand side. At the moment, we're using a water as the material. I might want to change that to air. So let's double click on the water icon, and we can specify a new material. In this instance, we're going to specify air. Another thing we may wish to do is we may wish to actually define the temperatures of these inlets. So for example, if inlet 1 is going to be a certain temperature, we can actually define that. I'm going to let that be 22. Inlet 2, I might actually wish to change this temperature, and I'm going to have this as a higher temperature, and I'm going to change that to 50 degrees. So we're doing a fluid simulation, but we're actually doing a fluid thermal now. That's our setup sort of complete. Just to go over another few things, at the moment we are doing a steady state simulation. In the explore mode, we can actually also do a time dependent or transient simulation, and those can be set up by clicking on this little icon down here, or we can choose it here and we can actually specify the duration as well. So once we've set up our simulation, we can hit the solve button, and within a few seconds we will start to get some results. So straight away we're getting results. One thing I will just do is I'll make these components transparent. Sorry, there we go. Let's make these transparent just so we can actually see the simulation through them. And let's look at it from this angle. So at the moment we're just looking at vectors, and we can see here our options to modify the actual how you view them. I'm going to change this to contours, and I'm going to turn vectors off. So when we change this to contours, straight away we can start to see how the flow of how the material sort of or air flows in this instance, and we can see that the top two outlets clearly get a lot more flow than the bottom ones. If you hover over this, we can actually see the flow. If you look at our results bar on the right hand side, hopefully you're seeing a value change as I hover over different areas. So we can clearly see that the velocity at the top area is around 1.5 meters per second. Moving down to the bottom, the second one, we're looking at like 0.6. If we move all the way right down to the last one, we're looking at 0.139. So the flow is clearly directed towards the top outlet. That might be something you wish to change. So if you do wish to change that, maybe you can make some design changes. So let's make that transparent or non-transparent again. And what I'm going to do is I'm going to section this model through this part. So I'm going to select these two opposite faces, and I'm going to go into what we call a section mode in SpaceClaim. And I'm just going to look at it from this top view. So we can see potentially that if we maybe make some changes to these ribs, will that maybe direct the flow a little bit more downwards. So maybe these two here, I'm going to use my move tool, and I'm just going to make these maybe bring them back slightly. So I'm just making a direct change to the simulation. The volume will update and we'll start to get some new results. So you can see I've just moved them down, and then we can start to see whether that has a direct effect on the simulation. What we can clearly see now is a lot of that flow is being directed rather than into the first outlet. We can clearly see it's being directed into the second outlet. It's probably got a higher velocity per second value. So you can see what we're doing, making live design changes, rapid exploration, and seeing what effect they actually do have on the model. So we can continue to make changes. We can try and even this out. We can change the size of these ribs. We can maybe add new geometry to sort of direct this flow more, maybe down towards these last outlets. But you're doing that on the fly. And again, like we did with the structural, if you want to take this into the refine mode or even transfer it to Fluent, you can do this in Ansys Discovery. For our third example, we're going to be looking at a thermal simulation. So for this example, we're actually going to be looking at what we call CHT, or fluid solid thermal. And again, this is another simulation that you can do in Ansys Discovery, and you can actually do this in the Explore mode. So again, using that graphics processor to get speedy results and rapidly explore designs. So we're going to start with the setup for this. Again, this is going to be have a cooling channel. So if I just make this part transparent, just so you can sort of see the cooling channel in this part, and then we've got these 3 transistors that will have like a heat source. So first of all, let's extract the fluid volume. So again, we'll go into that Prepare tab, use our volume extract tool, select the face with an opening, and select a seed face. So very quickly, we've just extracted the fluid volume, so we can see now that we've got these faces. And we can then start to apply some heat sources to these transistors. So let's triple click on them. Using our quick access guide here, we'll add a thermal, and we can add a heat to these, and we'll add a value of maybe 150 watts. So I'm going to triple click on the second one and add the same value, and I'm going to triple click on the third one and add the same value. If we look to our tree on the left hand side, we can now see that we've got those in our physics setup. So now we need to specify an inlet and an outlet. So I'll use this face as the inlet. Make sure that's set to inlet, and we'll specify a velocity again of 1 meter per second, and let's make this a bit cooler. Let's make it 10 degrees. So now we can specify an outlet and hit the tick box. So that's our fluid solid thermal conditions set up. What we can now do is actually look at the materials as well. So at the moment, again, this is defaulted to a structural steel. These transistors may be a different material, so they might be like silicon. So we can click on here, and we can then search for different materials. So maybe these are silicon, so I can just specify silicon for that one, and just do the same for each one. Set those to silicon. So I can change the materials. You can search for your own materials, and also one thing to mention is obviously we do have access to Granta materials, so that you can actually have an additional module to get access to a massive library of materials from Granta. So I'm just going to leave those as they are. The liquid is presumed as water, so we'll just keep it as that. So we've got these 3 parts of silicon. This is structural steel. Again, you can change your materials to suit. So our setup is sort of complete now. Let's hit the solve button and see what results we are getting. So instantly we're getting results again. So it is still converging, as we can see here. But straight away, just initially looking at this, we can see that the third transistor is obviously getting a lot hotter, which potentially could mean that there's not as much flow getting to that third transistor. So we can look at our high temperature again along here. We can hover over points on the model, and we can see that the third temperature is around 32. Second one, we're looking around 26. The first one around 23. So we could always put monitors on any of these to sort of hide the valve, find the value. So if I triple click on this one, I could add a monitor, and select a variable temperature. We'll select average, and then we could say the average temperature of that transistor is 31 degrees. If we now change our results type to velocity, we can see potentially what's happening here. So we can see that a lot of the flow is sort of going around, but not much is getting to this final transistor, which could be causing, well, probably is causing that one to get a bit hotter than the others. So so what we could make some design changes and see what happens if we had quite a drastic design change. So what happens if I actually remove one of these sections, maybe this first one, if I box select this area, make sure I only select the face that I want. And maybe let's remove it. So let's go to the design tab, and again, using that fill tool, let's get rid of that area. So you can see straight away exactly what's happened. I've removed it. The simulation will now start to re-simulate. We can see now, hopefully, that a lot more flow is getting to that third area, and our simulation will re-simulate. You can still see it's converging here, but we can straight away see here that we've gone from 31 degrees, that transistor, down to 25.9. So let's have a quick look at the temperature, and you can see we're getting a 26, 23.6 in the middle one, and a 26 in the far one. So the temperatures are now, you know, closer to the same, than a bit more average. We could again do a little bit more work, try and get a nicer flow all the way around the part. So that's just again a very quick example of a thermal, and showing you the power and speed of Discovery. We'll now move on to a topology optimization study.
Hi guys, hopefully the video was useful there, and you're able to understand a bit of the capabilities within Ansys Discovery. Hopefully you saw there 3 sort of different types of physics: structural, a fluids, and a thermal. We were going to show a topology optimization one, but unfortunately we haven't got enough time to show that. But just thought I'd just go wrap up on the presentation. So just to a quick summary, Ansys Discovery we do feel is suitable for all skill levels. It is a scalable solution, so if you start with Ansys Discovery, you can scale up to, you know, the high-end Ansys products. It's quite an easy user face, nice looking, very easy to use, and I say it is a complete solution. So it's a full 2D, 3D drawing package and a simulation tool as well. Sort of just so you're aware of how to engage with us, we can provide tailored demonstrations, we provide free trials, and support you through those trials, and we're also happy to build business cases with you. So if you do feel like getting in touch, use these contact details on this page. We have had a couple of questions, so I'll just fly through them. If I'm not able to answer your question, feel free to reach out. I've only got a little bit of time. So someone mentioned obviously cost of the package. Everything that was shown in this presentation is sub £6,000, so you know, not an overly expensive package. And another person mentioned, it was mentioned in the video, we can actually simulate on actual STL data as well, so we can actually run all those simulations not on solid bodies, we can actually run them on STL bodies as well. And if you someone mentioned trials, yeah, please reach out to us again, and any of the details here, and you can just reach out to us, and we can provide you with 30-day trials fully supported through us as well. So again, I'd just like to say thank you for listening to the presentation, and I hope you have a good day and some more interesting watch some more interesting presentations as well. So thank you very much.